Hi everyone. We're going to look at another example. This is a great one for you to try on your own. It's similar to the last one. I've just given you a little different shape to work with so you can compare and contrast what happens when your curve has a different shape and think about what's an overestimate and what's an underestimate and what does best. So I'll walk through, but definitely try this one on your own. Okay, so we're going from 0 to 3. And we want to use 6 rectangles for each of these. So the width of our rectangle is going to be 1/2. So this is kind of convenient grid. We're going to have lots of little rectangles to figure out. Okay, so first we're supposed to do left-hand sum, which means our picture looks like this. You can tell that. The left-hand corner determines the height of the rectangle. The top left corner should touch the curve. Okay, so there's my picture for L sub 6. This time we were not given a formula, so we do just have to estimate. So let's see, if this up at the top is 3.5, I would say this looks like about a 3.2. So this is maybe a 3.1, and this looks like it hits right on at 3. And then let's see, this is a 2.5. So I would say this one is 2.4, and this one is maybe 2.8. So again, some estimating. We won't all end up with the exact same answer, and that's okay. Just be careful. I'll be looking for things where you weren't paying attention and you clearly didn't get it quite right. Let's see, so 2, like 1.9. So for example, I drew on it, but it looks to me, let's go over here, like this is definitely below y equals 2. So if you claim that one's 2, I'm going to ding you a little bit for not being careful. And then when we go to find the area, so this is L sub 6, don't forget your width. The widths of these rectangles are all 1/2. So we're going to get 3.2 plus 3.1 plus 3 plus 2.8 plus 2.8 plus 2.4 plus 1.9. I'm going to run out of room. Okay, so let's see, what do we have? Some of these out nicely. So here's a 6. I have any more 6s? Maybe they're not so nice. Here's a 5, so we're up to 11. 6, 5. Go. And then what do we have in the middle? 11, 12, 13, 14. And then 14 plus 2, 4, 5.2. So it looks like I got 19.2. And I still have to cut that in half, which is going to be 9.6. Okay, so this is an estimate of the actual area, and this is even an estimate of L sub 6 because we don't actually know spot on what those values are. Alright, so let's do the same thing, only using right-hand endpoints. So now this first rectangle, and again we can steal some values. It should have the same height as my second rectangle did before, so this should be a 3.1. So notice things kind of switch up when your function decreases instead of increasing. And then this should be spot on at 3. This should be 2.8. So make sure you are consistent with whatever you decided before. This should be 2.4. I'm skipping one. 2.4. This should be my 1.9. And then the last one is the new one, but it actually looks really nice. It looks like it's exactly 1 tall. So for R sub 6, we'll sneak this down underneath. We're going to have 1/2 times 3.1 plus 3 plus 2.8 plus 2.4 plus 1.9 plus 1. Okay, so let's see what adds up nicely. 3, 4, 5. We still got that one. Plus 3. And then, here, we can do this. Plus 4. And then what are we missing? These seem 2 in the middle. 4, 5.2. Okay, so we have 5, and 4 is 9, and 5 is 14.2. So we're going to end up with half of 14.2, which means R sub 6 is 7.1, approximately. Okay, so that's our underestimate. Last one was overestimate. And then we have one more task, and that's to use midpoint rules. These might get slightly messy just because of how I chose my last value. So remember, you have to be consistent. So if we've already claimed that in that first rectangle, the height on the left-hand side is 3.2 and the height on the right-hand side is 3.1, the height in the middle better be somewhere in the middle. It's decreasing, so it should be less than 3.2 and more than 3.1. From there, it's estimating, so I'm going to say 3.15 because it's really hard to say. But I would say it's not always fair to just average the two y values. Remember that you want to use middle x, not middle y. It's just kind of hard to say exactly what that is here. This one needs to be somewhere between 3 and 3.1. So 3. And again, who knows, maybe, let's see, if it's concave down, maybe it'd be a little bigger. So here we can even do this just to really make my point. Let's say that we think that's more like 3.16, 3.06. And again, my point is make sure you're using the middle x, not the middle y. I don't want to trick you by making it look like it's the middle y. And those are not the same thing. When your function's concave down, it keeps getting steeper. So this should actually, if we use the middle x, it should actually be a little bigger than the average y value. Okay, then we're between 3 and 2.8, so maybe 2.9, and I am going to actually use 2.9 there because then I don't have to go out to extra digits. And then this one looks like, oh, I don't know. It looks to me like it's around a 2.2, but did I use a 2.2? Oh, I'm sorry, a 2.6. 2.6 or 2.7. And I know it should be between, oh my goodness, I'm losing them. What are we between? We're between 2.8 and 2.4. So yeah, something like that would be fine. I think it's about 2.7. And estimating is okay. Just make sure you're estimating using the middle x, not the middle y. I say that a million times so you get tired of hearing it and it sticks. Okay, so this one, we know it's between 1.9 and 2.4. I'm going to say it looks an awful lot like it's right at 2.25, maybe even a little higher, 2.26. Okay, and then last one, if we go right up the middle, it actually looks like it hits pretty spot on at 1.5. Okay, so for L sub 6, we get 1/2 of 3.16 plus 3.06 plus 2, need a jump, plus 2.9 plus 2.7 plus 2.26, make myself enough room, plus 1.5. Okay, and really just for laziness sake, we should be able to do that, but I'm going to plug it in my calculator real quick so you don't have to watch me be a slow adder. 0.6, 2.9. The good news is if you're in taking a proctor test, I'm pretty generous with time on those, so you should be able to take a minute to do some of this number crunching if necessary. 1.5. Okay, 3.16, 3.06, 2.9, 2.7, 2.26, 1.5. Looks good. So I get 15.58. That is not cut in half, which is going to give me about 7 point, well, this is really exactly 7.79. The approximately should go way back at the beginning. This is an estimate of L sub 6 since we don't have the equation. So I would definitely say that this time left is a clear overestimate, right is a clear underestimate, and again, mid in general should do better than either of those two. When you average left and right, you get a contest, but left and right on their own definitely don't do as well as mid. So that should be my best guess, but I can say for sure it's between 7.1 and 7.96. All right, thanks for watching.